Good morning, everyone. Thanks for joining us today for When Precision Counts, Creating Luxury Custom Jewelry. My name's Diane and I'm part of the marketing team here at Solidscape. Just a few housekeeping items before we begin today's webinar. All participants are in listen-only mode and your microphone is muted, but we do encourage your questions. Please submit any questions you might have by typing them into the lower right-hand corner of the toolbox panel, and we'll do our best to answer them during our Q&A session at the end. Okay, let's get started. It gives me great pleasure to introduce our panelists today. Joining us on our webinar is Jimmy Achdjian. Jimmy's the owner of GJ Systems in Armenia, and he's going to give us a tour of luxury custom jewelry and give us some insight on what it takes to make it. Unfortunately, Ruben Romero was unable to join us today, but we do have a couple of his slides that we will go through. And we are really thrilled to be joined by Darla Alvarez and Manuel Basmajian. They're both instructors for the GIA in Carlsbad, California, and the Jewelry Manufacturing Arts Program. So they're going to give us an overview of the GIA's Jewelry Design and Technology Diploma Program. What I'd like to do now is hand it over to Jimmy. Jimmy is the owner of Certus 3D of UAE, GJ Systems of Armenia. He's been a Solidscape reseller since 2003. He's a CAD instructor, a designer, a gem cutter, and also a graduate jeweler gemologist from the GIA. So Jimmy, I'd like to hand it over to you to take us on a tour of some luxurious and sophisticated jewelry designs.
Thank you, Diane. Welcome, everyone. When we mention custom jewelry, we directly know that it should contain rare gems, precious metal, and presumably one-of-a-kind design. Traditionally, the designer starts with a sketch that materializes in a drawing. A talented goldsmith used to directly work the precious metal or carve a block of wax by hand using different tools. This was before CAD/CAM. However, this is still applicable by a lot of jewelers in different parts of the world till nowadays. Today, the CAD designer, using a 3D software with virtual tools, commands, he starts with a sketch, an idea, that he converts into a realistic 3D file. The design is previewed by the customer and approves it before production. The designer can modify, control the final weight of the piece according to customer direction, and all of this with a couple of clicks on the keyboard of a PC. Next, the jeweler will transfer the CAD file to a CAM machine. The most popular CAM equipment is a 3D builder, the printer. Next slide, please. High-end jewelry commands high surface finish. That means, after polishing the surface of the precious metal, we should achieve a uniform reflectively with high luster. Therefore, the printed model should have a superior, accurate surface finish. To achieve this, we need a high-resolution, high-precision printer and a material that has flawless casting properties to avoid any porosity, flat spots, warping, and shrinkage. Now we will show some items where we will highlight what we mean by high-end jewelry. This ring is a proof of high-precision technology. It was designed in 3 parts: the shank, the ring gallery, and the stone mounting. In the ring gallery, we can see the straight square edge, 90 degrees sharp corners. We have the same square edge on the bridge side of the shank and negative. And the stone mounting, the crowns of the stone are perfectly round, with no shrinkage in any direction. And the top side of the shank again, the designer have created a kind of seating for the mounting. All of the above will allow us to have a precise assembly. Next slide, please. Yeah. This is a real special design, a ring that turns into a bracelet. The link of the bracelet fold together into a ring. It is made of several pieces that perfectly fit together. Again, this is possible because of the precision we are able to achieve with the printer. Next slide. With this item, we will cover casting sprues, placement, and removal. In high-end jewelry, a goldsmith's objective is preserving the integrity of the design. This pendant is made out of two parts. With the help of the CAD software, the designer placed the sprues in an intelligent way. This will help us get an excellent casting result, respecting the rules of flow of melted metal. Also, this will help the goldsmiths remove the sprues without harming the integrity of the casted parts. And of course, save him a lot of time in the finishing process. Next slide. On the left side, we have a free-form coral ring made out of 18 pieces that were perfectly polished and assembled. On the right side, we have a sapphire and diamonds ring made out of one piece, a real high-end classical custom jewelry. Next slide. On the left, the amethyst ring made out of two pieces, and on the right, the cameo ring and pendant set in a bezel setting. The cameo was scanned, then traced on the software. The file was printed, and you could clearly see how the cameo perfectly fit inside the bezel setting. Next slide. Here we're gonna talk about perfect polishing. Most of the time, high-end jewelry is made out of several parts. This allows the goldsmiths to easily polish the backside and underneath to achieve the best uniform reflectivity. Being able to polish the inside of a ring to perfection, this will bring up the brilliance and fire of the diamonds or the gemstones. Needless to mention that part assembly is a child game because all parts will click fit together like a puzzle. Little soldering, polishing, and we are done with a flawless finish. This is again the advantage of having these parts printed on a high precision 3D printer. Next slide. Oh, sorry. So I conclude with an important question to the goldsmiths. What a couple of more hours on the printer if you are able to achieve high surface finish, high precision, directly castable, ease of processing, ease of automatic support generation, and ease of support removal. I would like to say a special thank you to Highend Jewelry in Amman, Jordan, Mr. Samar Msih and his team, La Marquise Jewelry in Dubai, Mr. Paresh and Nishid Shah and their team, Gaffrey Jewelry, Mr. Gurgen Razarian and Yerevan, for their much appreciated help by providing these beautiful designs. Thank you for listening and thank you for your time.
Thank you, Jimmy. Thank you for taking us on the tour of those custom pieces. That was very, very informative. Unfortunately, like I said, Ruben was unable to join us today, but we wanted to give you a little bit of background on him. He's known for his diverse over-the-top custom creations. He's located in the Seabold building in Miami, and many of his pieces have been seen on musicians at the Grammys and on several famous athletes. He specializes in on-site design, and his services include 3D digital design, 3D wax printing, and casting. He himself has a small fleet of SolidScape S390s that help him bring his customer visions to life. So next I'd like to introduce Darla Alvarez and Manuel Basmajian from the GIA in Carlsbad, California. And Darla is a senior instructor of jewelry manufacturing arts. She has over 7 years experience as a custom jeweler. She does repairs, casting, fabrication, settings, and she's a CAD CAM pro. And we also have Manuel Basmajian. He started at the age of 13 in the industry. He's been 23 years experience in the jewelry industry. He's got experience with custom model design, wholesale manufacturing, mass production experience, and CAD. And what we'd like to do is find out a little bit more from the two of you about the GIA. You know, everyone knows the GIA is where you go for an education in gemology, but some folks might not know that that the school also offers a jewelry design and technology diploma program. So can you tell us exactly what's covered in this program?
Yeah, I'll field that one. There are 3 primary components to our course. We teach a CAD component, a design component, and a CAM component. And to kind of break those down, the CAD component, the actual software that we teach Rhino, and we do teach some ZBrush. Rhino, or Rhinoceros 3D, is a universal CAD software that the jewelry industry has really adopted, and most jewelers use some version of Rhino, whether they realize it or not. Even other jewelry-specific softwares, which I'm sure a lot of people have heard of, such as Matrix or Rhino Gold. There's even a newer one called Panther. They're all built upon Rhinoceros 3D. So we teach our students Rhino because that will give them the backbone to be able to take on any kind of software that they might encounter in the jewelry industry. A new and up-and-coming software in the jewelry industry is ZBrush, and it's an organic kind of digital sculpting software. So it's almost like working with clay. It's kind of considered like digital clay, and that's given people a lot more freedom and flexibility in CAD jewelry design. So we're trying to get on the front end of that to give our students something that they can take out in the industry and be that much more successful. Our design component comprises of teaching a software. It's actually a free software called Sketchbook. And what we do with that is try to get the students comfortable with digitally drawing things so they can communicate ideas to customers. It takes a lot of effort to create a 3D model in CAD, a lot of time, and if you get it wrong and you present that to a customer and it's not what they want, you've wasted a lot of time. It's very inefficient. So we try to teach them how to communicate that idea quickly beforehand, before they even start to design in CAD. We also touch on some different principles, elements and principles of design to hopefully encourage them to develop their own design language and style. We do also dabble in CAM, so the 3D printing aspect of CAD. They do use a 3D printer on site in class, so at least they gain some familiarity with what it is to prepare files, get them on the printer, get prints off the printer, and have some exposure that way. And we also talk about various technologies in 3D printing and hopefully get them at least comfortable with the language and how to discuss this with people when they go forth in the industry.
Great, thank you so much. I know a lot of people, learn CAD, but don't really understand the principles that make jewelry wearable. Can you give us some examples of what your students might learn that put them on the path towards becoming jewelry designers?
Sure. As Jimmy mentioned, the importance of manufacturability. We talk a lot about manufacturability in class, which includes the casting process, the functionality of the piece, and also the assembly process, which is really important to making sure you have the proper interlocking parts there. And also the final weight of a piece, because remember, your client will most likely have a certain budget that they want to stay within, and making sure you're not making a piece that costs too much money, kind of going over their budget and will not be able to afford it. We also do emphasize the importance of 3D printing, which can also be used as a tool to review the manufacturability of a CAD model. A perfect example would be to, once you're done modeling your piece, go ahead and print it out, take a look at it, and having more of a visual look on it definitely does help in order for you to go in there and go, you know what, this part looks a little bit too thick, maybe a little bit too thin. I can make some adjustments and print it again. So it's a wonderful tool to have in the industry. Also, while they're modeling at their desk, we also make sure that they have the proper use of, or know the proper use of using calipers to, again, another visual aid in the CAD modeling process. Kind of open up the calipers, take a look at it, see what like 1 millimeter looks like, what 2 millimeter looks like. It's a wonderful way of making sure that you're modeling things to manufacturability standards. And also along with that, we also do provide a 3D printed GIA CAD sample gauge for reference. And on there, we have basically simple objects printed on there with different dimensions, different thicknesses, different lengths, just to kind of have a different idea of, again, another visual aid to help modeling CAD.
Great, thanks so much. And can one of you give us a high level description of your curriculum for the process of starting after the actual CAD design is complete and ending with the wax prototype?
Well, yeah, I can take this one, Darla. So basically, to follow up on kind of like what I just said here. So once the model is completed, in CAD, we also learn to post-process them to make sure that they are actually 3D printable. In class, we use a software called NetFab to fix any errors that we'd encounter in the STL file, making sure that it's a valid and closed object before we actually send it over to the 3D printer. And excuse me, and also the students, as Darla mentioned, they do learn to operate the 3D printer in class just for a more hands-on experience.
Great, thank you so much. We know custom's really big and today's consumer really desires that unique one-of-a-kind jewelry. And can you give us some insight of how your students apply what they've learned at the GIA and the program to today's jeweler, the workflow of today's jeweler using CAD and CAM?
Yeah, well, what's amazing about CAD is it really provides more flexibility to the custom jeweler than the custom jeweler's ever had before. So it's just like a whole new world. A big part of the emphasis of our program is on digital rendering. So we teach students how to take their design and turn it into as photorealistic as a picture as possible that can be provided to a client. What's nice about that is you can make changes on the fly. So I can show this ring to somebody with, say, an emerald as the center stone, or a sapphire as the center stone, or maybe it has rubies on the side, maybe it has diamonds on the side. So it gives clients more of an opportunity and choices before they get the finished product. So 3D printing can also give customers an idea of what their piece is before they're holding it in the hand. They have a real 3D representation in their hand that they can try on, that they can visually see, is this what I want? And probably the best part of this is that we're able to provide customers with a jewelry piece without investing in the materials or the manufacturing beforehand. We give them the whole thing without that initial investment, which I think gives a lot more jewelers a lot more opportunity to serve more people. And our students learn how to do all these things, so when they go out in the field, they're ready to get up and running right away.
That's great. And what about the different career paths? You know, where might a typical student start after they receive their diploma? Is it typically retail, or are there other places that, you know, you find students working?
Well, a number of our students come from a family background in jewelry, so a lot of students do return back to their family stores, but there are probably just as many that kind of go out on their own. We get a number of students that strike out. They want to be the independent designer. So they want to be someone who starts their own jewelry line, and they're using this as the springboard to that. There's also a number of students that kind of become small scale designers. So they'll go and find a job in a more mom and pop local jewelry retailer. So a number of them do go more to that retail route. They may or may not make their own designs. And I think that group focuses primarily on custom work. And we do have students, however, that do go to large scale manufacturers. So they'll be creating CAD models for kind of already created designs. Designers will come up with the design and they'll create the CAD models for production purposes. But what's nice about this kind of career path is it could be a potential path to creating designs for a larger design house or becoming a design house jewelry designer themselves. And I'd say those are kind of primary jobs we'll see. Some students do go off to be more CAD/CAM service bureau technicians. So they're more in charge of checking CAD models for manufacturability and 3D printing those models for clients or in-house casting facilities.
Great, thank you so much. Well, we appreciate you giving us an overview of the program, and that was some great insight on the GIA. Now we do have some time left for some questions. If you do have a question, please type it in the box in the right-hand corner. The first question we do have is for Jimmy. Jimmy, this question came in. It says, can you explain more about the importance of the position and placement of the sprues on a custom piece?
Okay, if we go to slide 6, or sorry, slide 8. Yes, that's it. Okay. This is a perfect example for me. If you look at the sprue on the left side, like the piece with the setting, the pavé setting. If you look at the sprue, it is placed in a way where it's not going to hit the settings. So it's placed on the corner. Here we have the flow, the good flow, and we are not damaging the piece. Also from the bottom, if you look at the same piece in the bottom, we see also again the sprues that are connecting the piece from left and right to the middle piece. So in this case, we are able to cut the sprue from the bottom, and it is very easy for a goldsmith to clean the backside instead of cleaning the prongs of the pavé, like the beads of the setting. Also on the right side, the same, like what we highlighted in yellow, the same thing apply. Like it is always easier to clean from the bottom side than to clean on the place of the setting. So this is what we have here. I don't know if we can go to slide, let me check. Slide number 6. here also, like the mounting, the same applies. So the CAD designer decided to put the sprue from the side because it will not hurt the integrity of the design. It's very easy to clean the piece after casting on a flat surface. What else can we talk about? The slide 7. Slide 7 also the same. If we look at the first picture on the left, the flow of material, here it's not very clear, but like the X, this is used also for, we can, first of all, to secure the piece, and second, for the flow of material. The right one, if we look at the cullet, so it's we are not damaging the cullet, and here it's a very small piece. So imagine if we had the sprue on top. So we will definitely hurt the prongs of this one. There's no way that a jeweler or goldsmith can clean it easily. I don't know if this satisfies the answer.
Yes, I think that was a great explanation. Thank you for that answer. It looks like we have another question. Thank you, Jimmy, about what is the customer prototype made of?
Is this for me?
I believe that is directed to you, Jimmy.
Okay, it's made of wax. The prototype, they are made of wax, and typically they are samples that are coming from solid-scape machine.
Yes. Okay, great, thank you. And it looks like that's all the questions that we have for today. So I wanted to thank our panelists. Thank you, Manuel. Thank you, Darla. Thank you, Jimmy. And if we, once again, we know your time's valuable and we appreciate you participating in our webinar today. If there are any follow-up questions or you need more information, please feel free to contact us by visiting our website at www.solidscape.com. Thank you all for joining today and enjoy the rest of your day.
Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you, John. Thank you, everybody.
Thank you.